Everybody, thank you for joining us on another episode of the Builders Lounge. It's really a treat for us today to introduce Chuck Lynch. He is with AERA, Automotive Engine Builders Association. And really, Chuck, I am so excited to be with you. We've known you, I think, for a few years now, but you're such a wealth of knowledge. So it's an honor for us to have you on here. And hopefully, I'm just throwing this out there, we would love to have you on future episodes because the topics that you know so much about constantly come up on social media posts and other things that we do. So this is not going to be the last time that we want you on here, just giving you fair warning.
And likewise, we have a podcast as well, so we maybe reciprocate. But yeah, we're definitely open to that.
Yeah. and
our whole team, has a ton of history. So
yeah. Well, speaking of your podcast, the Engine Professional, which, by the way, is a Bible around here as far as the magazine goes. And same thing for the podcast. How long have you been doing the podcast? I think it's a few years, at least.
Yeah, we've got a few years. Quite honestly, we've kind of backed off a little bit because we're going to kind of change the direction and do, initially we were just an audio podcast. And you start driving yourself to the point where, okay, we need more visual. And as everybody's kind of moved into that, okay, it's a podcast, but it's video as well.
Right.
That suits us better because then we can start to show off some of the things that, pictures say 1,000 words. And so we're kind of moving that direction. It helps to tell the tale, right?
Right. Well, everybody listening needs to know that you guys are the pinnacle. We call it the Bible around here as far as your magazine and what you guys speak about. So it's like a second religion for people that it should be in our opinion. So tell us a little bit, Chuck, about yourself, about your background. You have so much experience so that the audience can get to know you on our end a little bit. Tell us your history.
So, my father was a machinist. Well, my grandfather as well. Oh. And I actually grew up more in the industrial machining world. I went into the Marine Corps, and that's kind of drugged me into engine repair. Yeah. My MOS was amphibious assault. I went to boot camp the day I kicked off boot camp the day Iraq invaded Kuwait. So August 9th of 1990.
Wow.
And so we went through mobilized school. They pushed us through long hours, extra fast, think of going to Kuwait. And when I got to North Carolina, we had 72-hour air alert. You're going to be going to Kuwait. They come and get me and a couple of other guys. And they're like, well, because if anyone remembers, it was just basically a bombing run. It was real short-lived. So they're like, well, whoever goes over is basically just part of the drawdown. So we need people ready when all this equipment comes back. And so right. I went to General Support Maintenance Company and GSM. So anybody knows the military, it's full acronyms. So General Support and Maintenance is actually an engine, transmission, rotating electric rebuild facility. So right away jumped into a facility that was building engines, transmissions, the self-propelled stuff. We had the fuel shop, electric shop. And I got involved in a lot of testing, so transmission and engine dynoing. So after I was come to the point, well, I am going to get out. I'm from Southern Indiana, so I went to work at Jasper Engines Transmissions. I did 20 years there.
Yeah.
I initially worked in the diesel engine division because that was my history.
Yeah.
And then I went into product development, engineering, but still my forte has always been machining. So I got involved heavily in jigs, fixtures, and the procurement of the equipment that we used in manufacturing. Probably helped start the transition to move away from traditional boring machines and seat and guide machines to do more of the CNC equipment and so forth. Then I left. I went to work for Rottler as a service technician for a period of time. Mm-hmm. And then I've worked for MALA. I was the production engine rebuilder application engineer. because I knew the players, right? And also I knew, their mantra has always been form, OE, form, fit, function. But when we repair things, we also need a solution, correct?
Right.
So as engine builders, we deal with things like spun main housing bores. We deal with, okay, I need valve guides to, oversize. I need undersize this part, oversize that part. So in talking to the engine builders and their needs, that's kind of the projects I worked on. And now I'm in a good place, with all the experience from looking at from mass production and, the individual, the smaller job shops, 1 to 3 man shops that I deal with. It's kind of helped round that out. And so, yeah, that's kind of the story. But yeah, again, it's been my son's a machinist, but he's in the industrial world too. But hey, we can all talk the same language.
Yeah. We got to store your guys' DNA or something. I mean, that's valuable DNA to go. What is that? 4 generations now?
Right.
Well, that's incredible. Well, that's so awesome. Thank you for sharing that. I didn't realize about your military background.
Yeah, that was a good time. One thing that's unique about the military, and I think that certain universities and stuff can say something similar, except you're not quite together as much as you are in the military. But what takes you there, you find yourself with a lot of like-minded people. So being a jarhead, the Marine Corps, you have a ton of folks that stay in touch forever. It's a true brotherhood because, you can't really help the neighborhood you grew up in. When you're in elementary school and high school and to some point universities, it's, university starts to be that, okay, I made the decision to go to this particular school, but it really shines in the military. So you make lifelong friends and, you can typically trust the guys around you to do the right things, so everybody struggles a little bit when they get out because that whole team concept, you kind of struggle with the, hey, you got guys who are only there for a paycheck and they don't really care about the mission. Right. And we didn't have so much of that in the military. People were really mission oriented in the Marine Corps, and
very committed.
That was good. Yeah. But it was also, it was a place where I picked up a craft that I'm like, hey, I really like this. Right.
It's in your DNA.
I mean, I grew up around Indiana. I grew up around sprint car racing and roundy round stuff. Love drag racing. So I've always been a gearhead per se. My first vehicle was a 67 Chevelle, old Ford pickup. And
man, most people would dream to have that as a car in general, let alone their first car.
Right.
And so how long now have you been with AERA?
We're at 5 years in the current capacity. Actually, between Rottler and Mala, I did a little stint with AERA and got recruited over to Mala and just, kind of directional change. I'm in a little different capacity here at AERA now than I once was. Yeah.
So educate me and everybody else that's watching. So you've got the Engine Professional Magazine, you have the podcast, then you have the certifications and training for that. You've got the cylinder head machinist and engine machinist. What other programs do you guys do or offer?
Okay, so I guess since you mentioned the machinist certification program, anybody that's been in the industry for quite some time knows that the ASE had an engine machinist certification program.
Right.
Now, typically they're dealing with more technicians. So you're talking, you got a couple 100,000 certified technicians out there,
right?
Versus less than 10,000 engine machinists. So it was difficult for them to, quantify to their board why they're doing this.
Right.
So there was a very friendly handshake agreement, between ASE and AERA that, hey, we wanted to do this and we wanted to drive the certification and give folks credentials, something that has value. And now we have this is not a hard number. It's an approximate.
Yeah.
It changes a little bit, but we have like 75 community colleges and so forth that participate
Really?
with the certification administration and so forth.
Wow.
A lot of the large production engine rebuilders use the program, and they use it as hey, it shows that a member of your team is putting forth some efforts because they want to get certification. Hey, if you want more money, what are you doing to improve your skills?
Right.
So training, continuing education is invaluable, but for an employer, hey, you got to put yourself out there too. You got to put forth some effort.
Right.
So what some of them do is like, okay, we will give you an increase in pay, and we'll pay for the certification if you pass. Some folks have, okay, if you try once and you didn't pass, then the next time you have to pick it up. And then if you pass, then we'll pay you back. So there's a lot of things like that. But like say about 75 schools participate.
That's incredible.
And then, so that kind of leads into, our flagship offering is our tech line and the Process Pro program.
I left that out, but we use that daily, several times a day at least.
Yeah. So we still have folks that don't prescribe to Process, but they're members and they just call the tech line. But the folks that are turning a lot of different stuff every day, they're signing up, they're using Process. And I guess to explain what Process is, we have a database. It's a web-based database that you have to be, a member to subscribe to. And we basically will take all of the service manuals and pick them apart, and we'll put the data out there in a format that a machine shop's interested in. Because if you just get the cylinder head, you don't want to look through a 3,000-page service manual to find valve stem to guide clearance, surface finish parameters, head thickness, things of that nature. You want to be able to just go to that part.
Right.
So we have it. It's in tabs, and you click on cylinder head tab, crankshaft, of course, is going to have main journals and rod pin diameters, oil clearances. We also have data like casting numbers, which is something, I get off track a little bit, but casting numbers mean less today than they did years ago.
Right.
You have to go more by features. Okay, it's an Isuzu, it's got an AB on it, but that doesn't really help with the identification, because even though they made some changes on the crank, it still has the AB on it.
Right.
So you need to compare features with the casting numbers. And sometimes there's no casting numbers to begin with, or forging numbers. But again, back to the Process, we have tech bulletins, and you mentioned Engine Professional magazine. What we've recently done is added, okay, so if you're in this particular application, for instance, 5-liter Coyote, you get a lot of questions about, can I hone this thing oversize? What's the construction of this? So we've got articles that we've done on, say, the construction of the engine, what you can do for repair, what sleeves are available, blah, blah, blah.
Yeah.
And so now we have those connected to those particular engine platforms. So when you're looking in there, you're going to see, okay, these are all the specs. Here's the technical bulletins for this engine. And then you can click on magazine articles that are supporting of that particular platform. You just print off the PDF. And that kind of got driven by a lot of folks calling us and say, hey, in such and such article or edition of EP magazine, there was this great article. Is there any way that I can get that where that's the only part that prints so I can hand it out? But
interesting.
For us to just print out particular parts of the magazine and send it to folks has been great.
Yeah.
And now, like say, attach them to Process. So you want to compile everything. Many times we have folks that are looking at that data before they even agree to take the job. But it's more and more common for folks to say, hey, do I want to mess with this? Is it within my skills and competencies to take on this platform? Do I have the right equipment? Can I buy the parts that are reasonable? Now when you got 4 and 5 timing chains and all these tensioners and stuff,
the special kits.
Yeah.
Yeah.
Can you make sure that you're buying good quality parts? It's not as easy as when it's a small block Chev.
Well, we do that all the time, where we'll go to that TSB section or the article section and just educate ourselves if it's an engine that we are training somebody to do, or like you said, where we maybe are taking on a project that we haven't had much experience with the engine. We'll go to that just to say, oh, here's some of the key failure points, or here's some of the certain tips that we should be aware of that we probably wouldn't have known if we didn't go to that section. So we go to that, like you said, almost first when we're training or educating ourselves on an engine. So we love that tool.
Yeah, good to hear that. That's the intent, and we hope that that's what folks do with it.
Yeah.
You know how it is, though, that a lot of times there's so many things that we offer. Like if you go to AERA.org and all the little tabs up top, and you don't have to be a member to see that stuff, but it gives you a glimpse into us. It tells the history. AERA's been around for 102 years now.
That's incredible.
It's, so you can look at the history, but you can also start to look at like tech links and, okay, hey, this has been valuable. This company has some tremendous information on piston failures or something like that. We have some hyperlinks that take you to their site, balancing, whatever. So we try to just continue to compile tons and tons of technical information and give you many avenues of getting to that information.
Right.
Of course, we have a YouTube channel, and all of our webinars are posted out there. So they're very technical in nature.
Yeah.
And by and large, now we do some webinars on how to navigate process. Because many times, again, we have people, every demographic and every skill level as a user of a PC, from they can't log in, they have to call to get help logging in, to they cruise around and they snoop into everything, and they're like, oh, what's this do? Because we have a piston speed calculator, we have compression ratio calculators, we have some sheets for cylinder, the things kind of that you would want to record if you're doing a cylinder head, a block, a crankshaft, or whatever, record all of your measurements. So we try to have a lot of tools. Again, basically, we want to be the tech resource that'll save you from having warranties, comebacks, and angry people, right? Yeah.
Yeah. Well, I knew that you guys had been around, and I think you did a big celebration for your 100-year mark, but that's such an incredible history to have, 102 years, and for you to be a part of a good portion of that.
Yeah.
So that with process, one of the things, and I use it not to the extent that our machine shop uses it, but some of those engines we've done because we just like machining and building engines. We've taken on some weird projects. How far back does that catalog go? Because I think we've done engines that are at least 40 to 50 years old, and we go to process and you've got information and specs on it. You know how old that catalog goes back, or how far those specs go back to?
Like 1915.
Really? Jeez.
Yeah. So you can, and we're anything from AERA to Zator.
Yeah.
You take a look at all of these global engines. Right now, we're adding 1,000 applications per year.
Oh my gosh!
Our current team.
Wow.
And right now we're approaching 16,000, and we're in February. So we're putting stuff in at a very rapid pace because there's so much stuff globally, that people are calling about. See, we're an international association. So every morning we come in to requests from South Africa, is very common, Australia. And so we come into those requests.
Yeah.
And we find that there's a lot of redundancy, right?
Yeah.
So
Sure.
I was just having a conversation with Andy. He's our most recent addition to the tech team.
Uh-huh.
And he recently went on on a cruise, and when he was on the islands, he was looking at applications that he never even paid attention to before on a cruise. And now, because he gets the questions about that stuff,
Right.
it's a new interest to him. And we get that with Australia and South Africa. So maybe it was used in Europe for so many years, and then now in South Africa, people, okay, so the years get confusing. The model years, so it can't pass a Euro 4, so they won't use it in Europe anymore, but they have different acceptances in South Africa. So that thing that was around from 2005 to 2011 might be 2024 there.
Yeah.
So we're constantly chasing after applications and engine codes and, okay, where does this, because when people call requesting specs, say 12.9 liter John Deere, what's in so many applications. So we have to replicate a lot of stuff, because this engine could be in a 80-30, a 90-50, whatever. So it's a challenge to do all of that in the industrial world. And I know this from like when I was at MALA, everybody's familiar, in the automotive parts world, aces and pies and how that stuff is all cataloged. But when it gets into the heavy duty, it's different. It's much different.
So what is your experience with that? One of the discussions that we've had recently is how something that used to work for, a few generations back, as far as the specs that they used to operate off of versus now, are different. I mean, the tolerances, the way things are machined are just different. So the theory that was used then and the theory that's applied now is different. Does that sound correct, or is that off?
Oh, 100%.
Yeah.
So as of late, post-COVID, engine bearings are something, Dan Bagley and I were just discussing this yesterday. A lot of parts you can do an analysis on and say, hey, this is like for like. Okay, I can get a valve from Ferrea, I can get a valve from SBI, and I can get a valve from Manley or something. And I can send them to a lab and say, hey, I want the chemistry. So the chemistry is basically the composition of that metal alloy, so the metallurgy. So they can say, oh yeah, this is 21-4N stainless steel, it's chrome plated, blah, blah. But when it comes to engine bearings, everyone has their own recipe.
Right.
And it's, okay, so it's sourdough bread. Well, this place in San Francisco's got a 120-year-old starter that they use for their bread, and that's their recipe and their strain of yeast. And the engine bearings are much like that. They have, is it like, there's a facility in Iowa that did the cast bearings for like all the top fuel teams. So centered metal is when you take some kind of just like your honing abrasives. You have basically a bond,
right?
So it has that bronze bond. They put the diamonds in it, and the other constituents would make that honing abrasive. Powdered metal seats are like that.
Right.
Engine bearings are like that to some point. But there also were bearings in the past where they use a lot of bronze as the bond material, and then they mixed it. And then you have a true cast alloy bearing. And then now today we have a lot of aluminum bearings. But to jump back further and go to kind of where your question is from, okay, the tolerance is what was acceptable then compared to now. So the whole bearing situation drove people to say, hey, can I take these bearing shells, take that facing off of them, and have someone to babbitt them? And I'm like, sure you could, but it probably wouldn't last around the block.
Right.
You have to think about when we did that with those types of engines, they were less than 6-to-1 compression ratio.
Yeah.
What's an average direct injected engine? 11-to-1.
Right.
You got some that are 13.5-to-1.
North of 10 for sure.
Yeah. So the cylinder pressure is going to destroy the bearing immediately. It just is not going to work. To use lighter weight oils, we've had to, increase the tolerances so that we have oil pressure. we're looking at efficiency, so pressure and flow. We used to look for a lot of oil pressure. Now we're like, no, we don't need so much, and so we use really light oils because what is pressure? It's restriction to flow. So we have real tight clearances. So we use real light oils. Right. And you have to understand, I know you guys communicate with Lake too.
Yes. He was on
the W doesn't mean weight.
Right.
But, it's viscosity. But, so those things are important. Now you have engines that, they're spec'd out at 0 W8.
Which is, unheard of not too long ago, I feel.
Right. And 0 W4 is coming. A gentleman
oh my gosh,
works with API, American Petroleum Institute, had shared some stuff. And he did a podcast with us. And so 0 W4 is coming. So you're going to have a hard time telling the difference between your fuel and your oil.
Really, that's that's got to be a difficult thing. I would freak out as growing up in this industry, seeing something like that. My initial thought would be that's not oil, but it's so that's some of the subject that our customers ask us about. They're like, well, I've always used in my diesel engine, I've always used 1540. I've always used that. And so in some of these newer engines, well, that's what I'm going to use no matter the weather outside, no matter anything, that's what I'm going to stick to. And that's changed.
I know that you have an engine test stand, the RMC engine test stand. I've seen the videos and so forth.
Yeah.
And so that's a perfect example of, hey, we were trying to keep engine testing simplified.
Right.
Okay. So we're going to run 1540 in everything. Okay. This is our test oil. We're going to run it to this temperature.
Right.
And it makes life easier for us. And it's just a standard.
Right.
And then you start to find out, well, these modern engines with camshaft phasers and so forth, it masked things. So they didn't, and again, we learned that we had to do PWM testing, and I know RMC does that, versus just turn it on and off. Because, initially when people were testing camshaft phasers, they just applied voltage, bam, it changed the cranking compression numbers.
Right.
And you turn it off and it changed. So it increased when you turned it off. Because you turn it on, it's retarding a bunch, right?
Right.
So they take those data points and say, okay, yeah, it works great. You put it in a vehicle, and a vehicle is PWM. It's not just turning it on and off.
Right.
So it's modulating it. And okay, now you're having these troubles. So you bring the stuff back and you find, okay, keep digging and find out, well, it only does that when we use the correct oil in it.
Right.
If I put this oil in here, it doesn't work right. It looks good to us, but we're not looking at the same data points. And, engine builders, we have that somewhat. We test maybe without a manifold, and we test, say, doing cranking compression.
Right.
Well, if I test it in my spin test machine, 9.5 to 1 compression ratio engine at 350 RPMs might be 220 PSI.
Uh-huh.
So I sell an engine to a guy, and he installs it. And he does cranking compression with 175 RPM starter, and he's 165.
Right.
Well, our numbers don't jive. And that's something we've got to fix. We've actually been talking with the folks about that. That's an industry thing that's got to get worked on, because we have technicians and engine machinists doing this stuff, right?
Right.
It happens.
It happens often. Yeah. What you're saying.
And it's just because we're looking at the same data differently.
Yeah. Now, talking about looking at data differently, how often are you seeing that in the industry where people are pointing fingers at each other, and maybe it's a process that we need to change, or like you're saying with checking compression, that that seems to happen more often than I would like to see it, is where especially between a machine shop and a mechanic, that they're saying, oh, that person did that wrong, or this person did that wrong. How often are you seeing it? Because you're on like the data acquisition side and dealing with a lot of this technical support. Is that pretty common? And
yeah, it's actually on the uptick, and we report to our board.
Okay.
so AERA has got a board of directors and so forth, and we report out once a month. And that's one of the things we've been sharing, is that we take more calls that are under hood diagnostics in nature, because they had a misfire. And so I was recently a part of a ASE task revision thing, and so that conversation was there as well,
Right.
because more and more of the technicians don't have any experience working on engines. They find this problematic component and they swap it out, right?
Right.
And so now, if you do take a head off, you take it to a machine shop. Hey, I got a misfire. Machine shop does what they do, but when they give it back, because we didn't find out what was the root cause, what truly was that misfire, then it's going back to the machine shop again.
Right.
And without kind of digging into what's going on, they just yank the part off again. So now I lose all of my evidence. You're back in, once you unscrew the head or something, you're in resolution mode, right?
Right.
There's no longer opportunity for diagnostics. You started tearing things apart.
Yeah.
And everybody's so quick to do that. So,
well, I feel like that's one of the reasons we became a machine shop. Well, I know for sure our first piece of equipment, our real piece of machine shop was an old Sun and head machine to do valve grinds and stuff on. And my dad bought that because he kept pulling off the cylinder head because he had a burnt valve or one of those reasons, would send it off to the machine shop and they would send it back. And then it was like, well, was it done right? Did it fix my issue? And so that's why he dove into trying to do his own machine work. And that's why he started investing in that equipment, so that when he pulled the cylinder head off, he could know, okay, how do I analyze this? How do I fix it? How do I determine what the real cause of failure was, instead of just saying, okay, I diagnosed it, I ran a compression test, the leak down came out of an intake or exhaust, just pull it off and send it to a machine shop, and then kind of keep your eyes closed and hope that it fixes it. And so that's why, that's how our machine shop started, is for that reason, so that we could know how better to assess and determine failure analysis and other things like that. A little bit about, I think, what you're talking about is a lot of mechanics now from a dealership or other things, they just like, okay, this is what the manual says, just pull it off and do it and hope that it fixes it.
That's the growth in our industry.
Yeah. Quite
honestly, is repair facilities that are buying a machine to resurface heads, and they get a seat and guide machine. That's the growth that we're seeing. I've seen it also with fuel injection shops who, like, okay, I keep getting these injectors back. They tell me to test them. Everything is, it's really dirty now, or, it was good when it went out, or it tests fine, but the guys are still fighting these problems. So you got fuel injection shops who are doing underhood work, and then that's driving them to add some machine shop equipment too. Yeah. So it's pretty interesting.
That is interesting.
What we've seen. But again, it's, vehicles are complex today. And so, diagnostics is so important. And you have to, a master tech or diagnostician is somebody that, they have to know how to think, right?
Right.
You don't teach them what to think, you teach them how to think. Mm-hmm. And, one of the other things that we offer as AERA is we have a tech conference the day before PRI starts. Mm-hmm. We call it EPIC. So it's Engine Professional Industry Conference. And we have 4 presentations to take that day. And ATEC went away. It was a 2-day deal, and it was, a lot of cutting edge stuff. We're trying to do, maybe not so cutting edge, mm-hmm. but something that you can put in your toolbox and take back and use it immediately. Right. So, again, we won't be out there. We're probably not going to do presentations on an AVL dyno that's $2.5 million that only a few people are going to be able to afford.
Right.
But what we did last year, this past PRI, is Chris Hammond from Lakeland Auto and Marine. He did a presentation on the Pico scopes. and he's kind of a pico power user.
Mm-hmm.
And so put that in front of the machine shops, these guys who do not do the diagnostics,
Right.
and let them, kind of see what a underhood technician has for tools and what they can get into. And so, he was showing them piston position charts and using a pressure transducer to, vacuum transducer. And, he called it finding mechanical issues with electronic methods.
Yeah.
And got great results as far as, the poll that went out. And so the more we can get the folks talking to each other, that's a chasm that has to be bridged. We got to fix that.
I totally agree. And that's one of the reasons that my dad and I started the social media, is because what we do is no secret. And when I say what we do, what mechanics and machinists do, there's a lot, like you guys provide a lot of technical information and what specs to machine things to, how to do that, how to do failure analysis, all of this stuff. And but to the average consumer, somebody that their butt's just in the seat and not knowing all those details, we wanted to help educate them on what we're seeing, how to maintain your vehicle better, and how to just do things and better in general, and just illuminate that to other people. And we're not perfect at it. Sometimes we behind the camera, or in front of the camera, excuse me, there's some things that we have an opinion on that we're still just throwing out into our audience, saying, okay, here's what we think. What do you guys think? What do you see? And so we're just trying to educate ourselves, but we're also trying to educate, like I said, everybody else to know how an engine works, how to assess it, how to be educated on it. And I think you're right. A lot of people in this industry and outside of this industry need to learn. And I think as a community, if we can help share that information and bring people together in this and make it fun and exciting, then the benefit is huge, I think.
Yeah, absolutely. And, convey that everything is a process.
Right.
Okay, why does the injector fire when it does? Everything is a process. And one of the things that it always strikes home with me, and coming from manufacturing facilities, is sometimes we don't follow our own rules. We try to get people to maintain their vehicles,
right.
Get your oil changed, rotate your tires,
right?
But set a mileage mark for when you do your brakes or something. And some of that stuff's automatic on vehicles now, but then we'll have all the tools in our shop that we won't maintain. And I always use, it's not maintenance when it's broke and you're repairing it.
Yeah.
One of the things Chris was talking about, his acronym of RTF, run to failure.
Yeah.
And we tend to do that in the machine shop or, the repair shop. Okay, why did this burn up? Because we didn't put oil in the airline and so forth. So, sometimes we don't practice what we preach, but everything is about a process, right?
Yeah.
You have to establish a process and you have to stick to it.
Yeah.
And that's the way the vehicles operate.
Right.
They don't, sometimes you start by pulling a rope on the crankshaft, and sometimes you go and get in the cab and turn the key, right?
Yeah.
There's always a process. Put the key in, or push the button, if it's a key fob. So they have processes. We have to create processes. And if we educate people about all of these processes, and, we talk about diagnostics, okay, you have to break down the process as it should be, not your opinion of what happened.
Right.
Okay, if you break it down into the big chunks and then, small bites, okay, it should have did this and it should have done this. And then so, no. That's not what it should have done. It should have done, okay, now, so we're better educated about this, and we can make better decisions and better diagnosis. Failure analysis is one of the things that we get a lot of calls on.
Yeah.
And many times when people see failures, they don't think it's theirs because they don't understand what propagated that failure.
Right.
Lack of lube situation or something. Oh, why did this piston seize in the bore? It overheated. It's always overheated and the ring gap was too tight, right? You hear that on everything. Why did they break the ring grooves out?
Right.
It's between second and the oil groove, it's busted. Rings are gapped too tight, too much pressure, and that's very seldom truly really the cause.
Right.
So when you actually learn these things, like a lot of times you see single-sided pistons they got the black death on them. It's roached the piston really bad. Mm-hmm. It's really a fuel wash situation.
Right.
But everybody, you didn't have enough piston to wall clearance or something. Mm-hmm. But, when somebody now explains to you and teaches you what the real root cause is, then, okay, yeah, I guess I've seen that a lot. Your dumb luck goes away, right? No more dumb luck because you know the real cause.
Right. So what do you think is, talking about, conditions and things and the cause of them, what do you think is the biggest killer to engines nowadays? Have you guys been able to collect that and say, okay, this is probably the top thing that's killing engines now? Here's the second most common thing. Do you have any grasp on that?
Well, for the oil consumption thing, there's so many of the low tension rings that so when the OEs were pushed to meet, higher CAFE standards. So corporate average fuel economy. Mm-hmm. Okay, we got to do things to improve fuel economy. And so low tension rings, but they want to be productive and efficient and cut cost for the manufacturer. So you've seen, not only did they go to low tension rings, but they also started reducing oil drain backs in the piston. Uh-huh. And then you get rings that are stuck in the bores and so forth. So oil consumption is probably one of the biggest complaints. And some of those are reasons why. And you look at Honda and Nissan, they had some recalls where all they didn't want you to touch the cylinders. They put a new ring or a new piston with rings that had better oil drain back so that those rings could work better if they were low tension.
Interesting.
That's one of the more common things. Oil has, and I was at a conference, this was with a Valvoline oil training conference. Mm-hmm. And they said that everybody is screaming about timing components because they've changed their oil so much and they've taken out a lot of good properties. Well, think about a timing chain for a big block Chevy. Uh-huh. What do you get? 38 links or something like that. I don't know the exact number. So if you look at the link to pin ratio, if I have 1,000ths wear per pin, it's not a big deal, right?
Right.
So now all these modern engines with big long chains, and we've reduced the quality of the oil, so they will have 1,000ths and a half wear in the link in the pinhole, times 150 links.
Right. Then
times 2 chains, so now everything has to work harder to keep caught up with that. So
interesting.
Here now we have timing chains that aren't lasting any longer than timing belts did 20 years ago.
That's so illuminating. I've never done the math to articulate it like that, but that makes total sense.
Yeah, back in my history, looking at qualifying parts from all types of manufacturers, and you don't know what you don't know until you're enlightened. Again, right. No more dumb luck.
Yeah.
But there are parameters around things like the smoothness of the bore that's punched through the link to interface with that pin.
Yeah.
So if you start breaking those apart and look at the surface finishing, it can be absolutely endless. Right. The things that you can look into.
Yeah. Now, is that going back to the oil consumption issue? We have some engines, I'm trying to think of the particular ones right now, but some say that it's normal to consume a quart every 1,000 miles.
There's the LS's, Subaru, they're one. I actually had talked to a gentleman with Consumer Reports on a couple of different articles for that particular reason. So, looking up some parameters that were shared. So you go to AllData or Mitchell or whatever and see their bulletins, and 1,000 for a quart and 1,000 miles is totally acceptable. And then we also tell people to never change spark plugs, and they're good for 100,000. So people get into, I don't check anything, and they just watch for lights and they destroy their stuff. Yeah. It's so expensive to destroy it today.
Right. Well, yeah, I mean, back to the timing chain thing, if you destroy an engine that's got 2 or 3, I mean, some have crazy systems, and then, the VVT gears, tensioners, all that stuff, if any of that goes, then it's the parts cost alone can be astronomical. But so that's one thing that I think is interesting, and that's been a pain point for some of our customers is just in our education with them. We'll say, hey, the manufacturer says a quart every 1,000 miles is normal. We get that on Audis and some other things like that. And customers are like, no way. That's crazy. Like, I've never burned oil on other vehicles that I've owned, but now the manufacturer is saying this, like, that can't be right, is right. Just their feedback to us. And it does, I mean, it seems like a lot of oil to consume every 1,000 miles. And that's going into if it's a diesel, your after treatment system. If it's a gas, then into your catalytic converter and other things like that. I mean, that what's the way to combat that? You said doing different oil drains and other things like that, but what's other ways to improve that, or is there any hope for that?
Some of the things. So reman engines, we can actually combat that a little bit by maybe specifying a different ring pack, and look at your oil drain backs and your pistons and so forth. Yeah. So sometimes the aftermarket tends to do a little bit better on the drain backs because they have some of the old philosophies of, hey, there's got to be oil drain back to the pin groove areas. But the OEs were trying to, hey, every hole that you drill in that piston or breakthrough slot or something is more machine time, right?
Right.
So they're trying to reduce stuff in manufacturing, and sometimes it's just they screwed up.
Yeah.
There's a fallacy to that. Now if you had a vacuum system like in the racing world, mm-hmm. you would do a better job of pulling it down, but you're not. That piston's changing direction a lot of times, and a lot of it just decides to it doesn't have the time to get away from it, and so it stays in the ring groove area, and it carbonizes. And it does a lot of terrible things because you know how hard carbon can be when you're trying to get it off of components. You're using grinders and whatnot.
Yeah.
Blake and I have talked about that. Carbon also is a terrible heat dispersant. It basically is like glass.
Yeah.
What's glass? It's an insulator, not a dispersant.
Right.
So.
That's interesting. So what's one of the topics that we wanted to touch on that we've gotten some comments on is some people out there are saying that they've resurfaced a cylinder head and they've just used a block with some sandpaper on it. And I don't know if you've seen any of those videos where somebody's doing that. And I understand that taking things to machine shop is not the cheapest thing to do. And so you're paying somebody on a professional piece of machinery and a professional their time to do something. And so some people are machining things with sandpaper. I've seen on a crankshaft, somebody will take some sandpaper and loop it over the journal and sand down a worn area, throw some bearings at it, and then the next clip in the video will be them with high RPMs, and they're almost racing it, and they say, see, the sandpaper worked. I didn't need to take it to a machine shop. What's your take on some of that stuff, if you've seen any of that?
Well, absolutely. And those things have been around for many, many years. Again, sometimes it's the whole dumb luck thing. When it does break,
yeah.
Well, it does so much damage. They don't know what root cause was.
Right.
So, it's easy enough to just, I've never had any issue with doing that.
Yeah.
Because again, you don't know what the failure looks like. But whether it's an old conventional head gasket, paper clay composite, MLS or whatever. So this is like a traditional composite gasket. So this is a, paper clay. It's got a body, you call it the flange over body thickness and so forth.
Right.
So that has a surface finish requirement that's different than MLS. MLS is going to be, very smooth.
Yeah. Like 20 RA or less.
Right. I'm kind of a fan of the RZ number. And I know you've had some conversations with Mark Malberg with digital metrology.
He's joining us next week. Yeah.
Okay. So, he can really get in the weeds on that. Nobody knows it better than him, but like there's waviness parameters too. And that's super important, but most people don't have the ability to measure that. But RZ is the 10 highest peaks, 10 lowest valleys. So, RA, I can have, a very aggressive finish against the part, or I can say it's all valleys. Right. And, so those can be leak paths, or they can be, if you had that against an engine bearing, it's going to chew the bearing up.
Right.
So, but anyway, when we're talking about those numbers, RA in micro inches, well, what's a micro inch? So if you were to take a hair follicle, I'm not going to provide one, but anyway, if you had a hair and you look at the hair follicle and then you were to slice it 2,000 times, that's what we're looking at. That's micro inches.
Yeah.
And we're going to think that we can put it on a block and push it back and forth. And then, there's parameters for surface finish. Those guys also are not measuring anything. So yeah. Again, sometimes you get lucky, or you just, it's dumb luck.
Right.
Or, you don't know what the failure looks like.
Yeah.
So to say you're getting by with it, are they really?
Right. How long did they get by? Was it 5 miles, 10 miles?
Yeah. Or was it to get it to the used car dealer and just get rid of it? And we know that happens a lot.
Right.
And I'm sure you guys have in the machine shop, this is one of the things, and I don't, being brutally honest here, there's a lot of, used car dealers who will bring stuff to machine shops. Yeah. And they'll want one seat fixed, one guy, a vacuum test, and it's got one burnt valve, and they don't do anything with the rest of it, so we try to coach folks, what do they tell the guy when he comes back because he's got additional issues? Oh, I took that to so-and-so's machine shop and they went through that head, No, they didn't. They did exactly what you asked them to do. And, because you were trying to get out on the cheap.
Right.
And then they blame it on the machine shop. So you got to protect yourself and say, okay, I will only do every seat. I will only do every guide.
Right.
Or take it down the road. And I know that you have bills to pay and you got to keep the lights on and stuff like that. But if you do too many of those kind of things, well, you'll have no customers, and it's not going to matter in the end anyway.
We went away from that a lot of years ago because we were getting requests from whether it was used car dealer or just a DIY person, some young kid that had pulled the cylinder head off and just had a burnt valve or something. He's like, hey, I just want to do this. And of course we always wanted to help. And you're right. Sometimes it's like, okay, well, as long as I let them know that it's an issue, then it's on them. Well, that didn't always pan out, that because inevitably that kid or that used car dealer would come back to us and say, hey, well, what happened? Why didn't it work? Or why didn't it last? And so we just didn't ever like putting ourselves in that position. And we really closed that off a few years ago, where we're like, we don't want to do that carry-in machine work. And that negatively affected our business for a while, because that was a lot of work that we were doing. I wouldn't say a lot, but it was some of the work that we were doing. And so we didn't have that revenue coming in. But long-term for us, we were just doing stuff. We weren't just replacing the one valve or the one burnt seat. We were looking at the cause, why it actually happened. or we were building a whole engine or a whole cylinder head so that it was totally right, not just band-aided. So a few years ago, we made that transition where we weren't just taking in that carry-in work anymore, unless we were doing it the right way and all the way to avoid those things.
Right.
And
so right there, goes back to earlier when we were talking about process. So and now you have a standardized process, and it's easy to publish that and say, okay, we don't do these halfway repairs.
Right.
Our process is to tell you to go see the next guy then.
And so I'm going to ask you to critique us here at our shop, and be as harsh as you need to be. But what kind of things would you change that we do in our process, or how we do things from what you've seen and what you've heard? Is there any advice? Because I ask that and tell you to be harsh because I know that we're far from perfect, and we with all the technology that's coming out and all the advancements, that there's a thing that we say that the normal consumer doesn't touch anything that's more technologically advanced or advancing than the automobile. Because people say, oh, your iPhone, and me and my dad have talked about this on social media. People are like, oh, your iPhone is the most advanced thing you'll probably touch. It's like, no, not by a long shot. It's your automobile and everything that encompasses in that. That's like one of the most advancing things that a normal consumer will touch. And so, having said that, I know that we're always trying to keep up with this training and this education and this information. What would you suggest that we do different, or what would you tell us to look out for in the up and coming years that we need to educate ourselves, or that we need to change our process on? What's your advice there?
Well, you're in a position that since you do installs, is, work on that communication and continue to help others. So, if it's communicating what's truly better needed, say with RMC or Rottler or whatever, Robin, whoever your equipment folks are.
Right.
And okay, what things are translating between the machine shop and the service side.
Right.
So customer service, you have to have that customer service hat on, and okay, how am I communicating from my service shop to my machinist?
Right.
When we do find root cause.
Right.
So, okay, well, man, we tend to have too many leaky seats that show up when we put heads back on. So how do we fix that? We do 100% concentricity tests at the seat and guide machine. And I can get off the rails on valve training stuff. So, I won't go into that too deep.
Yeah.
But, it's one of the things we spend a bunch of money checking cylinders, and a lot of people don't check their seat and guide work nearly as well as they do their cylinder work.
Right.
We put torque plates on. We buy profilometers to measure RPK, RVK, RK. We stick a bore gauge in every one, and we look for taper and out around. And then cylinder head stuff we don't check nearly as close, but that's what we take. That's the majority of the work that goes to most shops. The cylinder head first. It's the first thing that comes off, right?
Right.
And so, just make sure that we're communicating what we're finding as root cause, and make it improve both sides of the shop, and have processes.
Yeah.
Do what you say what you do.
Right. That's something as we've grown, especially, we've been around for 35 years, but as we've grown, that we struggle with. We have more people, and so teaching all of those people to follow a process or to communicate that, and even with ourselves, communicating to some of our team on all of those details is difficult. It's a lot more. We're not just machining one engine, and there's different. Even with like a 6.7 Power Stroke, for example, we have different levels of that. One with billet caps, one with just the stock cast caps, and So when we change those engines and then communicating that between the machine shop, the person that's speaking with the customer, and all of those other in between, it's difficult. So that is one thing that we have struggled with, especially the last 2 years, is that process and that communication. And so I think your feedback is good there. That's something that we still need a lot of work on.
Yeah. And trying to capture it all, that's tough.
It's way tough.
Capturing of it is because when you had a bunch of gearheads, there was so much tribal knowledge, but everybody is, again, I was talking about the brotherhood of the Marine Corps.
Right.
So they're so passionate about that particular stuff. Well, it's easier when people are passionate about it.
Right.
But when you get into where, okay, this is just the guy's job and he doesn't have that passion, then you have to have documentation and you have to follow rules. And why are rules written? They're written for the fringes, right? Because the guys who really care don't break the rules.
Right.
The guys who don't care make you have to have a bunch of rules. So it's getting more and more difficult all the time.
Yeah. Yeah. Well, I think that's where Process and your magazines and all that stuff come. Dave, especially for a lot of years, he'll even have our service writers read that. And even some customer service people that have nothing to do, so to say, with the actual process of machining. They're not working on any machines. Their hands are on a keyboard, not on a machine. We want them to read the Engine Professional and other things, because it's like the more that you know and understand this, and that it becomes, you said in the military, like a brotherhood, but the more that it becomes a passion and the more that you understand it, the easier it's going to be to make sure that the end result is excellent. Because you care about it, you understand what's going into it, and you understand all of the things that that the team has done to make the product great. And so, I think that's why we subscribe to all this information, is because it helps build that passion for people, or if not passion, at least their understanding with what goes into it.
Right. And sharing when you have hiccups.
Mm-hmm.
The impactfulness of it. Again, some people take it very seriously.
Yeah.
Like, I don't want to do someone a disservice, do a bad job.
Right. Not at all.
But some are like, well, is it really that big of a deal? And I used to use this analogy with, because again, I was working in quality systems, and I'd share it with manufacturing folks on the floor. And so you got to put a helicoil in something because someone didn't inspect the bolt hole well enough. And I'm like, wow, it's just a helicoil. That's such a big deal. I said, well, if you were to go to, you pick the store, convenience store, 7-Eleven, Walmart, whatever, and you get a chocolate bar, and you open the little flap, and there's chocolate there.
Uh-huh.
Do you trust what's in it? You probably do not trust that that's a good chocolate bar. Why is there chocolate under that flap?
Yeah.
So a guy who's got to use that bolt hole that's bad, that he's got to put a helicoil in, so he can put an alternator on or a starter or something.
Then he starts questioning
what's screwed up inside of that engine.
Yeah. Then he questions everything else. Yeah.
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 I mean, you planted a seed of doubt initially.
Right.
Now, you won't eat that chocolate bar that's $1.
Right.
And you want a guy to eat a $10,000 engine.
Right.
Yeah. So, trying to create that customer service mentality with your whole team. I mean, that's always tough.
Yeah.
The passion and so forth. But I think if people understand, okay, there's a scope to this industry, and, that, hey, we all want to provide a good service, that we want to be educated about the stuff and continuing education. We want to be the best of the best and understand why it's done. And, of course, we want to always work smarter and make sure that we're being efficient and fair in pricing and so forth.
Right.
I mean, it's tough because what's somebody willing to pay for?
Right. Right. Yeah. Well, they want to pay for value, something that is done to their expectations and that has been advertised.
Yeah.
Yeah.
So sometimes it's hard to, in your processes, break them down. They don't care that you have to maybe grind the seat after you cut the seat with your form tool because of the seat hardness and chatter and stuff.
Yeah.
What they care about is that it doesn't leak and cause them to have a misfire and a light on their dash.
Right.
So sometimes, you just, that impacts your efficiencies, but you have to think like that. What are they willing to pay for? They're willing to pay this amount, so the rubber meets the road.
Right.
So how do I get to a point where I can do it at a cost that, we can both live on.
Right.
And, I can sell my product and so forth. So that means you got to pick your processes apart and establish what they are and then follow them.
Yeah. Yeah. That's like I've said, I mean, that's been such a big thing for us that we're constantly trying to refine. I mean, some days we think we've got it nailed down, and then the next day it's like, oh my gosh, even shipping something out, how we packaged it we had a certain circumstance where it wasn't good enough. And so we're like, okay, we have to refine even how we ship things out or how we dress something, how we seal something up. I mean, there's so many things that we're constantly learning and evolving on that we're constantly trying to refine. So it makes it exciting, but it's a learning process.
For sure.
Yeah.
We're going back to process. Some of the things that we've added there, and I asked this, the members that are out there and listening and watching, if you have ideas on how to, how we can better serve you and in the information and so forth, that's like just a simple example was a guy's like, hey, when I get heads, or a guy comes in and says, hey, I want this head done. What's it going to cost me? Mm-hmm. He's like, well, there's so much stuff out there today. It's not, okay, it's real simple. It's a small block Ford or a small block Chevy or like, hey, I have this Hyundai that 1.8 that I want the, seat and guide work done. Like, well, how many valves is it? Are they solid bucket or is it dual overhead cam, single overhead? There's so many things about it. So now that we have how many valves per cylinder, the adjustment method and all that, just in the overview.
Right.
And so it makes that area busier. But, he was like, now I can quickly determine what it's going to cost me to do that head, or if I even want to. Mm-hmm. Whereas before I had to go break out books and search and, get online and, is this a dual overhead cam or is it, now we have stuff. You got 5 valves per cylinder,
right? Or
3 valves per, you got odd numbers and so forth.
Right.
So things like that to help us kind of streamline. So, we're always open for ideas. We like to hear feedback on that. Interference. We used to take calls every day. Hey, is this engine interference or not? Well, now we try to determine that and put it in the overview. I just took a call yesterday from a guy who's super helpful. He's in Pennsylvania and he probably shares more good tech tips and stuff than he calls and asks for info,
Right.
Long time member. And he's like, hey, this particular application, he goes, not only do you have to worry about it being piston to valve interference, he goes, I built the head and I didn't have the cams in sync and I was barring the thing over and just spinning the cams because you just stuck the chain and the gears on there and just spin. Oh, just valve to valve contact like a Harley or something. So
interesting.
So you got to worry about that. Just messing with the thing on the bench, you could bend valves.
Right.
Because the angle of the valve seat and the makeup of the combustion chamber, the intake and the exhaust valve can hit each other. So I have to worry about that. And I also have to worry about they could hit the pistons.
Right.
If I'm servicing this thing. So
there's a lot that goes into it.
Right.
Yeah. I mean, and that's what you're talking about. So that's interesting. Well, that's what I love about the community that you guys have created and that we get to be a part of is the ability to share that information. So we love when it's a two-way street. So anything that you guys want to ever share, please feel free. Well, back to your one of the first things that you said is, how some shops pay for the training and then they get a raise. That's how we've done it. Is we pay for the training, but then we also pay if they get the certifications, then they get a pay raise for that, because there's some people that say, the training, it's typically referred to ASE, but I think more and more so now AERA, they're like, is it really valuable? Is it really worth it? And we say, yeah, we pay for it. It's that valuable to us, because that information is power, and these certifications are super valuable, so that we know that not only is the person committed to go through with something and get that education, but that they, that person essentially becomes more valuable to us because they have more knowledge and understanding on how things should be done in the right way that they should be done. And then they're part of that community, and they understand it better. As if they have questions, they know how to get them answered. If it's not through us, me or Dave, it's through the process in AERA community. So we love it.
Yeah, and you can put that back on them to, I guess a couple of things, and sharing of like AERA and ASE and stuff. So this stuff comes from the industry as a whole.
Right.
So I've done many of the ASE test riding sessions over the years. And so there's everybody from small shops to OEs.
Yeah.
And you all get on the panel and you develop questions, and you leave that room or that session that you all agree that that's an acceptable method.
Right.
That is truly the way to find that root cause of problem or whatever. So it's not just one guy who has this idea that he's going to make you crazy with these test questions. And I mean, it truly comes from your industry peers.
Right.
And then, from the customer service standpoint, I mean, you put signs out there, hey, we have ASE, AERA, ASQ, these certifications.
Right.
We want to educate our folks, and so that they do a better job for you, Mr. Customer. But thinking about Mr. Customer, I mean, we put ourselves, when we're a customer to our doctor or a customer to our electrician or something of that nature, I'm probably not going to a witch doctor. I'm looking for some credentials.
They're out there,
and it's so. I mean, we expect it in those areas.
Right?
Why not prove that you're trying to improve yourself?
Right.
With some credentials.
Yeah. 100%. I totally agree with that. Well, is there anything else that you would like to let the viewers know that's important to you, or that's important to AERA, that you'd like to share with us?
That we truly are a community. I've seen a change. So when things were easier, we competed at a different level. Like, when we're all fighting for small block Chevy volume, all high volume small block Chevy stuff.
Right.
A lot of people kept secrets and so forth. And it seems like we've really changed, where as a community, and this member can talk to this member. So oftentimes we're a conduit of communication. We have the connections within manufacturers. We know by dealing with our members, say, okay, this guy is really good. He makes all kinds of upper bore repairs for C-15 Caterpillars, and this guy has this skill and whatnot. So We're more than just a tech spec thing. We're conduit for communication, connecting people. We have the tech and skills regionals. We travel around the nation each year. We typically do 4. It might be 3 some years and 5 some years. We're always pursuing educating ourselves too, because we all come from industry. But if we don't continue our education, when you call us, what are you getting? Some old has-been machinist that's not current. So we have to work on that too. So we have the same challenges that you do as far as staying current and being knowledgeable and so forth. So we have the same needs. So no better way to do it than do it together, right? So we attend tech training ourselves and conferences and so forth. So, definitely like to share that and
love
follow our social media too, so that, when we put these ideas out there or what's coming up, tech skills and conferences and so forth, you'd be privy to what's in your area, because with our regionals, we might be in your backyard.
Yeah. Yeah.
That's what we've tried to do, and we used to have a big show. The AERA had a big show, and there's some, retraction in the industry. And so these machine guys, I mean, it's pretty expensive for them to go to, there used to be 2 PRIs, right?
Right.
PRI East and PRI West, and the AERA show, and all kinds of reason they had to move machines all over. It gets really expensive. So
Very expensive.
now we,
Yeah.
we make an effort at the PRI show and so forth. But all of these things are, to help grow the industry. And we like say with these regionals, we can be in your backyard. There's usually 4 technical sessions. Vendors, they're usually 100 to 150 people. 17 to 20 vendors will have tabletops, and you get to meet those folks.
Yeah.
And maybe you're dealing with distribution. So the guys you would never get to talk to at the true manufacturer are going to be at these things as well. Well, right. Since it's small, and you have that opportunity to have, some one-on-one time and so forth. So yeah, they're a really great thing.
Yeah.
And again, we mentioned the certification, our tech line, we take calls on all types of stuff. We've got folks on the tech team from manufacturing to have had machine shops, worked in shops and so forth. So we answer so many questions about, again, I was sharing, the diagnostic stuff. The big thing that we have been challenged with, because it was pretty easy when it was just the machine shop stuff, but that's not what it all is anymore.
Right. Yeah. Well, thank you so much, Chuck. We really appreciate all that you've given our little business here and all the information. And thank you for all you do as well with Engine Professional and AERA. All of that information is so valuable. And for anybody watching out there, you've got to know these guys. It's a second religion around here, and we really appreciate what you do for this community. So thank you. And Chuck, we hope to meet with you guys again here in the future and dive into some more technical details as we gather some information for you. But
well, thank you for the opportunity.
Of course, happy to have you.